there. So essentially what we do is we push an authenticator to an API client, and then that starts to establish a dynamic identity against our platform. What that means is that on a configurable interval, it sends off a cryptographic heartbeat to our ledger, right? Each one builds off of the previous and forms a chained identity on our platform.
That was part of a conversation that we had with Anusha Iyer. Anusha is the CEO and founder of Corsha, a security organization and vendor that is changing the way we think about API security by implementing multifactor authentication for APIs. Now, if you're wondering what is multifactor authentication for APIs, don't worry, you're not alone. I was in that boat as well, and we're going to find out exactly what that is in the podcast coming up with Anusha. But right now, it's time to take a look at our breach of the week. This week's breach of the week is going to be a little bit different because we're going to be looking at some security research that's just come out from GitGuardian. Now, GitGuardian is a company that scans all kinds of assets for secrets. These are API keys, security certificates, credential peers, anything that you don't want an attacker to get their hands on. And the report focuses on how many of these secrets were discovered publicly throughout the year of 2022. And the results are a doozy. In this year's report, 10 million secrets were discovered in public repositories just on github.com. The results were really quite shocking. Over 20% were for data storage, things like databases, Amazon S3 buckets, and another 20% was actually for cloud provider keys, giving an attacker or a potential attacker access to someone's cloud infrastructure. One of the standout figures for me was that 1 in 10 developers throughout the year actually leaked a secret. So this throws cold water on the idea that it's just a few junior developers that are making these mistakes. And we also saw large prominent use cases where credentials were actually leaked for organizations on GitHub. What comes to mind is the Toyota T-Connect breach, where public GitHub repositories were hosting credentials that gave access to customer databases of Toyota. The report also looks at how many secrets are actually leaked in internal and private repositories and also on companies' infrastructure, and it's quite alarming. What we know is that API keys are leaking through source code, and these are being used by attackers as a way to enter your infrastructure. So what can we do about it? Well, there's a few things that we can do. We can prevent keys from going into our source code using Git hooks. We can scan for them. We can use secret managers. But what we can also do is introduce multi-factor authentication on these keys. And this is something that Corsha and Anusha are working on directly. So without further ado, I'd like to introduce Anusha, who's going to lead us in our conversation on exactly what is API and machine-to-machine multi-factor authentication and how it might change the way we think about security.
Absolutely. Nice to be with you both here today. So I'm Anusha Iyer. I am the CEO and founder of Corsha, and we're an API security company based in the DC area, just outside of DC in Tyson's Corner, Northern Virginia. And a little bit about my background. So pretty much just an engineer by training, actually. I've been in the cybersecurity space for about a little over 20 years. Started off in the DC area at the Naval Research Lab, spent some time there, moved around in this area. And then prior to starting Corsha, I was with a firm called Galois, and they specialize in formal methods, cryptography, high assurance systems, ended up managing some DARPA programs for them in that realm. And a lot of that helped us kind of define Corsha and the problem space we're trying to tackle.
You guys are helping with API security. So what exactly, are API keys for anyone that needs a refresher, and how are they used? And why do we need to secure this?
Yeah, great question. So, it's when you think about API identity, authentication, keys, when you have one service talking to another service or one machine talking to another machine, right? And we like to think of machine as anything that doesn't necessarily have a human identity backing it. It's likely communicating over APIs. And that authentication ends up happening basically in one of three ways today, right? It's either keys, tokens, certificates. And the challenge with this is that those methods end up basically being system passwords, right? They're oftentimes static, they're long lived, and what's really scary about them is that they're shared, especially when we're talking about automated pipelines, any sort of automated workflows. You're going to have maybe workloads coming up and down, and you're not going to have a way to provision a unique independent key or token per workload that easily, right? And so what ends up happening is these keys become effectively the identity for those API clients. That's what you're using to authenticate them. And increasingly, adversaries are capitalizing on this weaker aspect of identity and access management and stealing these API secrets. And can you really tell in this bearer model of authentication whether it is a legitimate API client or if it's a nefarious one?
Yeah, and it's exactly right. If you have the API keys, you have the keys to the kingdom. And and if you find one API key, it may give you access to a system where you can find more, move laterally. So it's a big issue. How did we end up so reliant on API keys? What kind of caused us to all pin everything on this one this one token and not add other layers?
Yeah, it's a tough problem, right? When you talk about machine identity, and these machines now are, they're oftentimes these very atomic things, especially in application ecosystems that are constructed of tens, hundreds of microservices, and they're ephemeral and coming up and down. How do you provision identity for these things? Well, I think that DevSecOps folks will tell you that keys ended up being kind of a natural way to do it. And you can do things. So, for example, take like OAuth 2.0, right? And you look at um, flows within OAuth. There are a lot of good answers for using that to help humans connect into systems, right? And that's oftentimes backed by proving your identity in multiple ways. But when you talk about API to API or service to service communication, that defaults back to something called client credential grants. Now, the issue with client credential grants is these are specific, this flow, this part of the spec was specifically designed for passing authorization, not meant to be used as authentication. But to date, there doesn't seem to be a better solution. And so that's why we're still using certs, keys, tokens, and hopefully that's kind of our uh, mission at Corsha is to kind of elevate machine identity to the same level of sophistication and control and security as human identity and access management.
That's interesting. You would make a distinction there because I've never really thought about that distinction between authorization and access. How would you define that fine line? What is the difference there?
When I think authentication, I think proving identity. I have to prove to you I am who I say I am using whatever means. Authorization is okay, once I have proven to you who I am, then you have via policies, via, entitlements, whatever it may be, a way to say, okay, Anusha can access all of these resources.
Definitely part of the whole IAM thing. But yeah, the first part is like, who are you? Second, like, what can you do? That makes perfect sense.
Right. Which is why, these keys end up being proxies for identity. But if you share them, then you don't have strong identity.
So you talked about MFA for machine to machine identity. Now, when I think of MFA, I think of getting a text message or using my Google Auth app, getting in an email. Right, it all feels very manual. When we're talking about APIs and machine to machine communication, typically we're talking about thousands of requests, data going back and forth, and so how do we add MFA into this process?
Yeah, I mean, you're spot on. It's so automated, right? It's got to be self-servicing. Obviously, no little robot in the mix pressing the notification button on your Google Authenticator or whatever. So we've tried to use a lot of the same premises security guarantees that we get out of human MFA, but bring it into the world of APIs, into the world of machines, and have a lot of parallels there. So essentially, what we do is we push an authenticator to an API client, and then that starts to establish a dynamic identity against our platform. What that means is that on a configurable interval, so think on the order of minutes, hours, whatever your risk profile is, it sends off a cryptographic heartbeat to our ledger, right? Each one builds off of the previous and forms a chained identity on our platform. Now, when it's time for that machine to actually make the API call, in addition to whatever its primary factor is, maybe the API key, for example, right? It now can also produce a one-time use credential off of this moving identity. It's just a composition of what it's sending off to the platform, right? And that one-time use cred gets kind of seamlessly added in as an extra header to the API request. Just like human MFA, in front of the API service where we want to enforce MFA, we drop our proxy. That's now going to be looking for those extra headers, pull them off, and then check it against the out-of-band element of Corsha's platform, right? That's holding these machine identities. If there's a match with the identity, right, this moving identity, you let the call through, otherwise you block it. So really analogous to a TOTP, but just kind of a stronger story actually, right? Because it's not time-based, it's really one-time use, and you can operate without any kind of human involvement.
You mentioned there just at the end TOTP. What is it? What is exactly is a TOTP, and how are the two kind of different?
Yeah, so with a TOTP, like say Google Authenticator, right? It's generally what ends up happening is you have your Authenticator app and you put in the code that you have in the Google Authenticator app, and it's going to match. It's like time synchronized with what the time the server has, right? Your authentication server. Now, what that means is it rotates generally on like a 30-second limit. If someone were to get a hand on that TOTP code within that 30 seconds, they can use it as many times as they want, right? Versus if you have a truly one-time use MFA credential, the minute that credential gets used, it's worthless.
So I'm curious, just on the pure technical implementation side of this, like how onerous is this? So I think the great worry of all developers is like, oh, it's one more thing to implement, one more agent to set up, one more. So what does this look like from on the ground?
Yeah, it's a great question. Yeah, the goal here really is to take the burden off of these already overburdened personas within our software organizations, right? And so a couple of the angles that we took as we were developing this and trying to really be empathetic to that issue particularly is make sure that this could be a no code change required solution where it really is drop in at kind of a deployment or infrastructure level where it's post code both on the proxy and the API client side. And because of that, we have just a bunch of different form factors to kind of fit easily into an environment. So, we tend to be a very cloud native, almost Kubernetes native solution. And so really easy to hook into like a Kubernetes based ecosystem via Helm and drop us in as an extra library chart. And then that way it just becomes part of like natural deployments and you're not having to build it into like roadmaps of development cycles and things like that.
So, if I understand correctly, Corsha can kind of sit almost as a gateway, like in front of you or between, let's say, between your machines, where they're communicating with each other, and the machines are sort of looking for certain kinds of authentication, and you're basically adding another set in that's based off what you're calling like this chain of authentication. It's a continuously rolling. Is that right? Have I got it?
Yeah, that's spot on. I feel like we need to take you on the road with us now.
No, well, look, I have some advantage because I know my whole life at the moment is all about discovering secrets, and Dwayne and I both work for Git Guardian as advocates, and it's what I find fascinating about this conversation is that what we do is we find these secrets code. We find these secrets when they've sprawled into places where they're not no we're not meant to, right? And try and make sure that they're confined. What you're doing is a different approach, and you're saying, "Hey, this is a fundamentally flawed system. We need to add in another person into this stop," which will put us out of business. But that's okay because it's going to make the world secure.
Well, I think there's actually a lot of harmony there, right? Because, and we recently sort of put out the survey report that I think you all probably know even far more intimately than we do, kind of the extent of the problem. Um, but what we're finding is there's still a lot of these primary credentials. There's value in them in terms of being primary identity, holding still authorization, and so forth, and that hygiene of like the sprawl I'm fascinated by in terms of what you're actually seeing happening.
Yeah. What it definitely is, it definitely has some synergy, and I was joking a little bit there, but but do you see this as something that we could ultimately solve? So I said at the very start, like I think of course you're like solving the bottom turtle, and what I mean by that, if you're not familiar with the saying turtles all the way down, the world is held up by turtles standing on top of each other,
Yes.
right? But there's always a turtle underneath, and that's kind of what it feels like with secrets. There's always something underneath with this. Using Corsha and looking into the future and adding these other elements, do you think we're going to be able to move past security that relies just on APIs? Or do you think that we're always going to have some issues with this and that we can solve portions of it, or perhaps certain companies can strengthen certain elements, or can we actually solve this security issue?
I'm obviously a little biased, but I will say yes. I think we absolutely can solve this security issue with this type of approach, and we have patterns of history to corroborate that, right? So when I think back to sort of how we've seen human MFA evolve, right? When we first started deploying human MFA, it was largely um, within enterprises, right? Employees would come in and then they had this burdensome, I've got to do this extra thing beyond putting my password in, and it became almost a just natural employee enforced or enterprise enforced mandate. And then we expanded to cost of doing business, increased it to partners, vendors. And now, quite frankly, my mother can download Google Authenticator from an app store and knows that's best practice. So we've seen this evolution of moving past just username, password. And that's, everyone knows that that's not good enough. And um, I think the same thing, that same parallel evolution is possible and will happen on the API side, where we start, I think the analogy is we start perhaps with like internal APIs within an ecosystem where you need the enhanced protection, then extend it to third party connections. And then eventually, the analogy is you pull down one of our authenticators from Docker Hub and you're off with it and you seed it, and you now have the ability to have MFA against, a large public API.
Rereading your report that you put out recently, one of the most shocking numbers that pop out of that, and it makes sense, but it's something I guess I just haven't never read before. Was like over 40% of people are managing 250 plus APIs. That's a lot of services tied together. Like that's a lot of security overhead. And there's a lot of these numbers are popping out of me, but maybe you could talk a little bit about like your findings, anything that shocked you out of that report.
I mean, I would say that was one of the ones that was most shocking is like over 250 service accounts, keys, certificates, service. We actually do a lot of work on the federal side. And I'd say that number is even higher in some of those circles, especially when you're talking about like PKI. right? Because the US government invests heavily in kind of going the PKI route. Now, I think you're absolutely right. The other thing that really stood out to me was how much time that security conscious organizations are spending on things like key rotation, right? Like if you want to maintain any sort of hygiene, then it's got to be a regular part of your process. And it's so onerous. And I'm sure you all are seeing, the vast majority of organizations aren't even doing that.
No, yeah, that's exactly right. They're the ones that are investing the time in key rotation, other areas. We release our a report as well, and that's very different ways of looking at it. So they're very complementary. But one of the numbers from that is that in an average size company that has 400 developers, they'll have over 1,000 unique credentials that will be sprawled in 13 different places that are just in their source code. These are like in where they shouldn't be. These aren't total. So it would take, just to investigate all these incidents, it will take a team of 4 AppSec engineers the entire year doing nothing else. This is the problem that we're at, and so these numbers, while shocking in your report, yeah, I get it. It's such a big problem. What led to this report here, and maybe we can explain to the listeners exactly the report that we're talking about.
Yeah, absolutely. So this past month, and we've been working on this obviously for a few months prior, but we released a survey report around kind of API credential usage, secrets management within organizations. And we ended up, I think, having over 400 or so respondents within kind of DevSecOps, software engineering, infrastructure level positions walk through the survey for us, and quite surprising, even alarming, some of the results that we found. And so we wanted to share it with the community. One of the reasons that really motivated us to do the report is it's sort of an invisible problem because it happens behind the scenes, and these vast application ecosystems are run by a few oftentimes, right? And it is, there's so much opportunity these days to quickly spin up environments with the beauty of orchestration, with moving to cloud, digital transformation, all of that stuff. But what oftentimes is invisible is the burden of getting that secrets management problem right. And you see these alarming numbers, and we know when we read them, they're all accurate, but unless you see them, you don't really feel it.
Number in here that I really freak out about is that there's 72% of respondents use a secret manager, yet 54% are still concerned about a potential data breach. So there's a couple of things in there. Firstly, 28% aren't using secret managers. What are they doing? So that's the first thing that I'm worried about. Yeah, but of course, and then the other one is that 56 are still concerned about a potential data breach. Well, that's a concerning number for me, because I think more should be, because I don't think a secret manager is enough. A
Is
secret
enough.
manager can store your secrets, but it's not going to stop them from getting out there. So it's important. But that is
Yeah.
a great report that we will share the link over in the description, that everyone should check out, that Corsha have, and to stay in tune.
Yeah, I did have one other question for you, Anusha. Always curious about the names of companies. Like, where did Corsha come from? Like, when I first heard it, it's like, oh, it's a online training company. That was literally my first gut thought. Was like, oh, it's a course, like Coursera. And then the more I heard, it's like, oh.
Oh,
So I'm always curious, like, where did this actually originate?
oh, that is a great question. Um, do you want the long version or the short version?
I always like long versions. Go for it.
Okay, so I will start with Corsha is not our first name. Our first name was actually uh, hashlet, right? And the idea was that we were lighting up logins with hash codes. Now, came the interesting piece there was we did not really recognize the drug reference there. And I remember going actually into a podcast, maybe it was a webinar or something like it was a panel webinar, I think. And the other folks on the webinar prior, when we were introducing ourselves, like, oh, where did that name come from? And we're like, okay, this is not going to work. So then we went back and huddled and had to do a whole DBA, like change the name. It was like this big thing. And Corsha stands for, at the core of what we do is secure hashing algorithms.
I am so glad I went with the long version.
Yeah, and I would say, we had like teenage kids, like grown up. We should have run the idea by. So naming is hard.
Some funny stories about naming. I was a co-founder of a startup called Compago. Still exists, but Compago, we couldn't come up with a name forever. So we typed in some words into Latin kind of dictionaries, and we were all about bringing connection between carriers and clients. And
Yeah.
Compago was connection, and then it was just 4 years of Compagio, Comprodro. No one could pronounce it right, so I wouldn't advise a Latin word. And I was working for a company called Suncyre, spelled Cuncyre, and it was just years of spelling Sun Cyre or what. I can't even remember now, but startups always spell things. I think Corsha is a great name with a great with a great story behind it.
Well, thank you.
So as we come to the end of the podcast here, just for the people listening, obviously we're going to link to Corsha and to the report that we talked about here. But if people want to find out more about this topic in general, do you have resources, places where people that they should follow to kind of keep in touch with what's happening?
Yeah, absolutely. I mean, I would certainly say Git Guardian's blogs, right, is one that I would definitely highlight. Um, and there are, some great players in the API security space that are putting great content out there. It's a very emerging, like fast moving space. So certainly on the likes of, some of our friends at Salt, for example, right? They've also put out some interesting survey reports and things like that. um, and just watch the news, right? There's so many API related incidents that we are hearing every day now, that it really helps to keep a pulse on where adversaries are moving and where they're targeting to. And I'll also draw out another one of our partners. Dark Owl puts out some really nice content in terms of what they're seeing out there actually being manipulated and on the dark web and so forth. So I think understanding the problem space and sort of the extent of where adversaries are going is huge.
That's fantastic. Well, thank you so much for being with us today, and sharing not only about Corsha but also the journeys that you've had there and what we can do with security into the future. So I do hope that we'll be able to do more things together. And again, thank you so much for being on the Security Repo.
Likewise, thank you both for having me on.
Yeah, thanks for being here.